Getting into chapter 8, first day, new quarter. This chapter is going to last us the whole quarter, and that is a lot to say about this chapter because if you think about it, we did one chapter to start the year in 2 weeks. We did the second chapter in 2 weeks, and then we took 4 weeks on the third chapter, which is a lot, but if you consider that we're actually going to take this whole quarter for this chapter 8, it means that there's a lot of stuff in here that we need to be ready for. Today's lesson is going to introduce you to 3 processes. The first process is called finding the degree of a polynomial. The second process is called writing a polynomial in what we call standard form. And the third is called adding polynomials. So those are the 3 things you need to get your head ready for. Each of these processes are important throughout this unit, so be sure to work to understand them because if you do not learn it, you're going to get confused when the conversations continue to get more and more complex. A monomial is any combination of a coefficient and variables. The word mono typically means one. If you think about headphones, whenever they have mono headphones versus stereo headphones have a left and right signal, whereas mono headphones only have one signal sent to both ears. But again, monomial is simply one chunk of information. Because we can use that word, it should help us understand it. So here are some examples of monomials. 5 is a monomial because it's one chunk of information. 6x squared is a monomial because it's one chunk of information. 8x squared or 8xy is also a monomial because it's one chunk of information. Even this, negative 3.5, that is a decimal attached to some variables. Negative 3.5 t squared uv is a monomial. Okay, so all those are monomials because they are all one chunk. A polynomial, on the other hand, is a monomial or a sum of monomials. So even though I said that all these are monomials, you could also call them all polynomials because it's just a general word for it. But a polynomial is either one or a more than one. So the word poly typically means one or more. Here are some examples of polynomials. Notice here you have a monomial here, a monomial there, which means this whole thing is a polynomial. We cannot call this a monomial because there are 2 terms. This represents 3 monomials, 8x squared, 7x, negative 3. 3 different monomials makes it a polynomial. So again, this is not a monomial, but the whole thing is called a polynomial. Here we have another polynomial because it has 1, 2, 3, 4 chunks of information, so the whole thing is called a polynomial. Some polynomials have specific names. A binomial is a polynomial with 2 terms. If you think about a bicycle has 2 wheels, this is called a binomial because it's got 2 terms. So that would be a binomial there. Trinomial is a polynomial with 3 terms. If you think about a tricycle having 3 wheels, this would be considered a trinomial. And so those are words again that you need to kind of understand. Again, all these words are important in understanding the communication. You will not be quizzed on what they mean, but you do need to understand those, at least the general idea of those words to keep up with the conversations that are going to be going on in class. So let's get to the stuff that we're going to be learning about, which the first is the degree of a polynomial. The degree of a polynomial is the extended process based on finding the degree of a monomial. So in order to find the degree of a monomial, we must be able to count the number of variables in a term. So let's look at some monomials real fast before we do the polynomial and see if we can identify the degree. Again, it's a very simple process. Something you can do, you just have to make sure you practice it. As I said earlier, take pride in it, and it should work out for you. In this, if we count the number of variables in this term here, all we have here is an x, which means that this degree would be a degree of 1 because there is 1 x attached to that. 8a to the third, the whole term. The variable, I have 3 a's attached, so the degree of this would be 3. Very simple. 20, I have no variables at all attached. Guess what? This degree is 0. 2, b to the 8c. In terms of variables, I have 8 b's and 1 c. That is 8 here plus 1, which makes the degree 9. That's how you find the degree of a monomial. So again, if there's 1 variable attached, it's 1. 3 variables attached is 3. No variables attached is 0. 8 plus 1 variable attached, which makes it 9. That's it. If you want to find the degree of a polynomial, we simply find the degree of each term and choose the highest number. It doesn't even matter if there's a tie, just choose the highest number. So if you're asked to find the degree of this polynomial, you look at this and say this degree is 3, this degree is 2, this degree is 1, this degree is 0, The overall degree would be 3 because 3 is the highest number that I have. That's all. Just make sure you learn how to do the degree of each monomial, and really that's all you're practicing there. If you're asked to find the degree of this, you say there's 1, 2 variables here. There's 2 plus 1, which makes 3 variables here. 2 plus 2, which makes 4 variables there. 2, 3, and 4 being my degrees. The overall degree of this polynomial would be fourth degree polynomial is what we would call that. Second thing we're talking about today is writing a polynomial in standard form. If you're asked to do that, you're being asked to write it from its highest power to its lowest power. The most difficult part of this process is being sure to consider the sign attached. Most people who miss it, it's because they take a -3 and they write it as a +3, so as long as you don't do that, you should be okay. Again, this is best learned by practice, so let's try a few now. If they want you to write this in standard form, notice that this is a regular y, this is a y squared, which means this should be written first. -2y squared plus 5y would be standard form. Notice you have 2 y's down to 1. That is descending order like they want, and that's all you have to do to write it in standard form. If they ask you to write this one in standard form, again, the first thing you do is say what's the highest power. It's this one, so -3c to the 7th. The second highest power is this one, so plus 8c to the 3rd. And then the last thing we would do is put plus c. Notice my c's go 7, 3, 1. That's going down. So everything is based off of the highest power or degree of each term. That is how you put it in standard form. Writing this one in standard form, again, the first thing we do is say the highest power here is x squared. The second highest power would be -3x because that has 1x attached. The worst would be the +4 because that has nothing at all attached. And that would be what we call standard form. Okay? So again, nothing tough about that, just like there's really nothing tough about the degrees. As long as you practice like you're supposed to, I think you should be fine today, and actually I think you'll be fine definitely this week because there's really nothing tough so far this week that you need to be afraid of. The process of adding polynomials is the same as what we call combining like terms, which is why this shouldn't be so bad. Today's problems will be straightforward, and that all we need to do is understand what we can and cannot be put together. Let's look at some examples real fast. Again, this plus sign just means that you're putting this together with that. And so what you can do is say 4 w's and 9 w's go together to make 13 w's. -5, +2 go together to make -3. There you go. That is your polynomials being added, and it's even in standard form because I have 1 w dropping down to no w's. I would say make sure you put everything you can in standard form. That way you don't run the risk of missing any small questions that ask you to do it. Simplify 8t fifth plus 3t to the 4th plus 3t or t to the 5th. In this case, we actually have 2 t's to the 5th that can be put together. 8t to the 5th plus t to the 5th makes 9t to the 5th plus 3t to the 4th. That is your answer. So again, that's all we've got to do whenever it comes to adding polynomials. Again, it's just like whenever you add like terms, the difference is that they give you much uglier terms, which should be or is supposed to be more intimidating, but once you understand how everything works, it's not that bad. Simplify 4x squared y, 6xy squared minus 8x squared y. Keep in mind these all cannot be put together. You must read carefully. This has 2 x's and 1 y. This has 1 x and 2 y, so these are not the same. This has 2 x's and 1 y, which means that these two are the same. And so you end up with -4 x squared y plus 6xy squared. So do me and yourself a favor, work hard to practice this new material today. I am not so much concerned about how far you get. I don't care if you finish. If you're working to finish and doing it wrong, you're really not helping yourself. I am more concerned that you work as hard as you can to get as far as you can with the material. So if you only get 10 questions out of this whole worksheet done, but you really learn those 10 questions, then you'll be fine for tomorrow. Now, if you get to number 30 and you really don't know it, then you're just screwing yourself because when the quiz comes up at the end of the week, you're not going to know what's going on. So the answers to this are on the back wall for you to check. Do not use that wall to simply copy your answers because, again, I'm not collecting the sheet and you're just hurting yourself. Copying the answers really doesn't do anything for you. So make sure you're working through it and then going back and checking 2 or 3 questions at a time. Excuse me. Definitely Do not simply work all the way through the sheet, because if you're missing 10 questions, you want to know about it before all that stuff pops up or before you get to the end of it. So good luck today.